All right, so we're going to talk about how to solve any scalability issues for a web application or multiple web applications. So if you're an entrepreneur and worried about what do I do? How do I scale my app so that when we have a lot of people visiting my web application, that it scales? Or if you're a developer thinking, how do I build my app in a scalable way so that when we have a lot of traffic, my application won't crash? Or imagine you're a developer who are getting ready for technical interviews and you need to answer specific questions from the hiring manager that are probing to see if you understand how to system design. Some of these knowledge and concepts will be helpful for all of those scenarios. So let's jump right in and talk about that. So there was an earlier video where I introduced about the IKEA store analogy. And the IKEA store analogy helped you understand how web application works, including HTTP request and response, the components of what makes a web server, what the workers do, what the databases do, and so forth. Now we're going to talk about scalability. But before we talk about how to scale in a technical sense, let's go back into the IKEA store analogy. Okay, so imagine the IKEA store again. And the way that it worked is we had 3 lines of customers, and we had receptionist, and they handed off the order form to the workers, who then talked to the warehouse manager, who had all these parts stored in different cabinet drawers. Right? This was our IKEA store workflow. So imagine that we have this store, and let's say it's my store, and it's booming. And we have a lot of people waiting in line. And it's booming so much that people are waiting in line for hours now. Let's say they're waiting for 5 hours. And you're happy because, let's say, we work at this IKEA store. We're happy that there are a lot of people visiting, but the customers aren't happy to wait 5 hours. So imagine that, again, I own the store and I call you out and say, hey, I need help here. My store has a lot of people and my customers are angry. They're angry that they have to wait 5 hours, and a lot of my customers are leaving the store, or they're not even entering the store because they get tired of waiting in line. So imagine I called you and say, hey, I need help. What can you do? Can you help me? Okay. To make this analogy even more interesting, instead of me just asking for help, let me turn that around a little bit and say that I'm actually looking for a general manager to help me manage the store. And I come and say, hey, I need a general manager who can help me solve this issue. Are you interested in applying for this role to be a general manager? Okay, so I think that will be a little bit better question where you now have to be a little bit more active. Okay, so imagine I come to you and say, okay, I want to hire you, or I want to see if you're interested in applying for the general manager position. If I do hire you, what would you do to fix this issue? So go ahead and think about that. What would you do? My IKEA store is really busy. Customers are waiting in line for 5 hours. They're leaving. I'm not happy. I'm looking for a general manager who can fix that. So if I hire you as a general manager, what would you do to fix it? So go ahead and think about it. You can even pause the video and think about that question to see how you would solve it. Now, imagine that before I went and talked to you, I also talked to a bunch of different experts out there. And I asked them, hey, my store is having issues. What should I do? And imagine, I come up with all these different, answers. Some say, do this, Michael. You need to hire workers who speak certain language. Oh, there's this new warehouse inventory system called blah, blah, blah. You should do that because it's way better. What? You're using receptionist that are that's old. You need to hire receptionists like this. Some would say, oh, you need to host your cloud in Amazon or whatever, or move to a bigger store. I mean, the list of ideas would just go on and on and on. And imagine that's what I got when I talked to the experts. I got so many different ideas about how to scale my store that it was super confusing. So imagine I did all of that and came and asked you, what do I need to do? What would your answer be? Would I go and hire more workers? Hire more receptionists? Fire my workers who speak, let's say, Python and have them and hire people who speak C# or C++ or Java? Do I go and get a new database? What do I do? Do I get a bigger store? Right? Do I change, maybe increase the number of lines tenfold? What could you do? Okay, if you answered any of those kinds, all of those are wrong answers. It's not the right answer. What is the right answer? Right? Well, the right answer is you have to first listen and understand what's happening inside the store. Okay, so we'll come up with a few different scenarios. But imagine that what was happening in the store was this. Workers lined up. They talked to the receptionist. The receptionist is super quick, gives it to the workers. Workers are super quick. They get things done in, let's say, 0.1 second. And what's happening in the majority of that 5-hour wait time was happening in the warehouse. So imagine in this particular warehouse, this warehouse manager, the way that this warehouse manager organized all the different inventories was, he organized it a certain way, but when workers came and talked to the warehouse manager and said, hey, look, I need 4 IKEA silver legs and 2 tabletops that are black, the way that the warehouse manager organized and operated was he would go to the first drawer, open it up, look, and see if it has that part. If it doesn't, close it, open the second drawer, third drawer, go to the second cabinet, do the same thing, one by one, walking through thousands, tens of thousands, maybe millions of cabinet drawers. Maybe at the 99,547th drawer, finally open. Oh, there's that leg. Picks it out and repeats that process for every single inventory part. Can you imagine how long that would have taken? Let's say that is why it took 5 hours, because it was so big. So do you go and just hire more workers at the database? Well, that wouldn't solve it. How do you solve this? So if that is the bottleneck, again, any scalability issues that you find in web application, if you do bring it back into a real world example, like the IKEA store analogy, you will be able to find solution. It's not that hard. Engineering is not hard. You just have to break it down to simplicity and look at it and try to fix that bottleneck. Okay, so the bottleneck is obviously the way that the warehouse manager is pulling inventories is not efficient, extremely inefficient. So imagine if that was the case and you, with the wrong advice, you fired your Python workers and you got Ruby workers instead. Even if Ruby workers were fast, which I doubt, maybe you shaved off 0.00001 second out of that 5 hours. Does that really make a huge difference in your customers being happy? Oh, thank you. Now, instead of waiting 5 hours, now I have to wait 4.9999999 hours. So thank you for firing all your previous workers and hiring a new worker. No, customers will never say that. They don't care. They will still be pissed. Right? You have to fix the bottleneck. So how do you fix that bottleneck if database was the issue? I mean, that example is kind of ridiculous, but I see that problem a lot in companies that I helped and projects that I've seen, where it's not organized the right way. All right, so what do you do in that situation? Okay, again, that situation is like you go to the library and you ask the librarian, hey, I'm looking for a Harry Potter book. And the librarian says, go and start with the first cabinet, pull out one book at a time and go all the way to the end until you find it. Ridiculous, right? If you go to the library, what do they do instead? They have like a catalog or an index. It's like a book. You open up the book, and it could have on the first column the name of the book, and then on the second column it says aisle A57, dot something. So you just have to look at the index. Oh, that part is in A57. You walk over to A57, you pull it out, right? That's what a database index is. It's basically just like that catalog, where it lists either the name and where it belongs, okay? Now, imagine if I had this catalog, same warehouse manager, and say, hey, before you go and open the first drawer and open one drawer at a time, go in and look up that index first. Now, if you did that, and if you had millions of drawers, cabinets, how much faster do you think your warehouse manager is going to find the inventory now? 30% faster? 50% faster? Absolutely not. It's usually orders of magnitude faster, maybe 1,000 times faster, maybe 10,000 times faster. Again, depending on the volume of your database, right? All of these workers are very quick. So if you only had 10 drawers to open, right, your warehouse manager, it wouldn't have taken that long. But if you had millions of drawers, the amount of time it would have taken would go really, really high, right? So that's the concept of index. You can also go overboard. So you can imagine, oh, everything just index, right? You can imagine if you indexed everything, that index book can get really big, even bigger, until it can actually become bigger than your warehouse. So that's also the mistake that a lot of people make sometimes, is they overdo it. Instead of creating a light index, now instead of taking 5 seconds for the warehouse manager to look at the index and walk over and find it, the index is so big that it takes longer to look up the index than just going and finding it, right? So you can over-engineer. You need to find a good balance, but at least the concept of index is introduced here. All right, so that's how you fix it. So imagine that was the bottleneck. That's what you fix. Imagine in another case, that wasn't the bottleneck. What was happening was the workers. That was the first scenario. Let's say the workers were the bottleneck this time. For some reason, the receptionist hands off the order, and the workers are just really, really slow. Because and it's not that they're slow, they're performing 1 million steps to assemble a simple IKEA chair. 1 million steps, but they're doing it super quick. You're going like this, and they do that 1 million times, but it's taking a long time. And you can say, hey, like, move your hand faster, so they go really, really fast. But still 1 million operations, and it's just not efficient. Right? What do you do in that case? And just intuitively think about that. If you're assembling a simple IKEA chair, do you need 1 million steps to follow? That's kind of the overkill, isn't it? I'm just intuitively, that doesn't seem right. That's wrong. The instruction manual is crap. Right? You don't need 1 million steps to assemble a furniture, right? You kidding me? Whose fault is that? Is it the fault of the workers? They're working really hard. They're assembling things really quick. It's the fault of the person who created the instruction manual. That's what the developers do. Developers' job is to write instruction manual for these workers to follow. You can imagine a good developer can say, assemble these furnitures using these 7 steps. A bad programmer will say, assemble these furniture using 10 million steps. Again, that's the job of a developer. What are the steps written in? Again, the core building blocks of software. There are 5 things. Everything in the world in software is created using these 5 building blocks, right? But you can write the instructions in that 5 building blocks either in 7 steps or 10 million steps. Okay? So imagine that was the problem that I did 10 million steps, and you said, oh, I heard C++ is so much faster, so I'm gonna, fire these workers and get C++ workers to do that 10 million. Maybe you're right that C++ people can actually do that 10 million steps 10 times faster. But that wasn't the problem, was it? The problem was that the instructions were inefficient. The developer wrote poor, inefficient instruction to assemble HTML and CSS and JavaScript. Okay? What you do is you coach your developer and say, hey, learn about big O notation, learn about how to write more efficient code, and rewrite. And then everything would be solved. Usually, these workers are really, really fast. That a lot of these operations can be done in 0.0001 second or less. So this is why the discussion about which programming language is better usually is a nonsense. Because even if you got this down to 0.00001 second using another programming language, even if that's possible, right? When I've done benchmarking between C#, Java, Python, PHP, and the major ones, they're all about the same. There may be 10 to 20% performance difference here and there, but they're all about the same. So even if one was true, and definitely 10 times faster, it really makes almost zero difference in most of the web applications, right? Because the bottleneck is almost never here. If this was a bottleneck, it's because of the inefficient instructions that the engineers wrote. So you go and have them rewrite the code and say that 10 million line of instruction to assemble that furniture for customers who are looking for XYZ is ridiculous. Rewrite it, refactor your code. Okay, so that's how you fix it. Let's say that it was a little bit more complex. Okay, so let's kind of draw, the same store again. Let's say what was happening was, and maybe this is a little bit related to the previous one, but let's say that the bottleneck was again somewhere over here. Maybe it's not 10 million, but they're visiting the warehouse, let's say 500 times to assemble a furniture. What they do is the workers go to the warehouse and says, hey, I need this one part. And then they get one part, do some operations. Hey, I need another part. They do some operation. Hey, I need another part. They do operation. Go back and forth 500 times. Okay, that's inefficient. Very inefficient. You should just go to the warehouse once and says, I need parts, ABC parts. Can you get it to me? Get it once, make one trip, assemble it together. Okay? That sets of instruction, how you piece together the final furniture, again, that's coding. You just write the instructions using the 5 building blocks basically, and that's how it works. Okay, so that's how you can solve it. Let's say there's a bottleneck over here. Customers waiting in line. They type something in the browser, but when they type something in from the browser, right? So let me draw that a little bit better. They type something in the browser, and for that request to travel across to your server, let's say it takes 2 seconds. Right? As a general rule of thumb, if your website doesn't deliver the final content to your customer within 3 seconds or less, they're gonna leave. They're gonna keep clicking on reload, or they're gonna leave, right? So you gotta deliver that response within a few seconds. But let's say that trip to the web server took 2 seconds. It'll probably take 2 seconds back to go back too, right? So even if your server was super quick at processing the order request, it will just take too long. What do you do in that case? And why does it take that long? Well, it could be that your server was in Africa and your customer was in US and West Coast. So the distance, just the physical distance was long. Well, then move your server to where your customers are. Or maybe set up 2 stores, one for customers in Africa, one for customers in US, or so forth, right? You kind of get the analogy. So if that was the bottleneck, I mean, it would have been stupid to fire these workers or to get a brand new database, right? Okay. There are some other examples too. Imagine that all of this was super fast, but the final furnitures they walked out with, which was HTML, CSS, and JavaScript, was huge, huge, really big. So imagine your car was only like this big, but the car had to carry all that amount of data back. And your internet just slow. So imagine this was like 10 megabytes of data, and your internet can only transfer 1 megabytes of data per second. How long would it take? And your server can be like, oh yeah, I created that 10 megabytes of data in 0.0001 second. But again, if it takes 10 seconds for that information to go, your customer's not gonna think their internet's slow. They're gonna think your website is slow. So what do you do in that case? Well, do you really need to send that 10 megabytes of data back? Can you compress some of the CSS, some of the JavaScript, some of the images? Can you compress them? Do you really need to send a high resolution image when it shows up like this big on the web browser? No, you don't need to do that, right? Do you need to send 10,000 images, which would actually make 10,000 trips to your web server? No, why don't you combine some of that and kind of use one image and break it apart, right? There's some of the advanced techniques. Why don't you minimize CSS and JavaScript? Get rid of empty spaces that you don't need, right? So those are, why don't you zip it? So those are some of the techniques you can use to solve that bottleneck, okay? All right. So let me explain some other things. What other bottlenecks could you anticipate happening? Bottlenecks can happen at every single step of the way. In some rare cases, you may find that this is the bottleneck too, right? Let me address that topic a little bit. Usually the web server, the reception is not the bottleneck, but let me introduce a new concept. In the analogy that I'd explained is where people line in 3 lines to talk to the receptionist. The method that I explained is what is called a thread-based web server. Right? It looks like 3 threads, right? 3 threads of people waiting in line, right? The first person in the line, okay, first person in line is the first person to get the part, right? So that's called a thread-based web server. And Apache HTTP, which is one of the popular receptionists, is a form of a thread-based web server. But is that the only way to take in orders? No, it's not. Imagine that there's another order system. And it works as follows. What you tell is people just all wait. And what you say is, whoever fills out your order form, just come and hand it off to the receptionist. So they walk over, hands off the order form to the receptionist. And the receptionist says, okay, when your order is ready, I'll call out your number. So let's say this person was the first person to submit the order, second person to submit the order, third person, fourth one. Does the second, third, fourth person need to wait until the first person gets the order? No, not in the system anymore. What about the previous system where it was thread-based? Yeah, they had to wait. If order number 1 was really big, everyone behind the line had to wait, right? But in this event-based system, they don't have to wait. They fill out the form. Even if they were late to the party, if they filled it out fast, they just give it to the receptionist, and the receptionist calls out the order when it's ready. Okay. Now, there are pros and cons to both approach. And some applications, you do need it to be a thread-based. And yes, other customers waiting in line, all of that is worth it. Then you go with the thread-based. Sometimes that is the right choice. But in most of web application, event-based web server works just fine. So Nginx, for example, is an event-based web server that takes in the customer orders, right? So these are some of the things. All right. So now let's go back to the analogy. So in review, if the IKEA store is having scalability issues, right? If I was to interview you again and say, hey, my website is having issues, it's having scalability issues, how would you fix it? If I hire you as a developer, you shouldn't say, you need to use C++, or you need to use Python instead of Ruby or instead of PHP. You shouldn't say you need to use, MongoDB, or you're using MySQL, Postgres is better, and MariaDB is better. Okay, that's basically the same as spitting out all the answers that could be right, but without really understanding the problem. What you need to do is, well, I would go and find the bottleneck. How would you find it? Well, you can time it. Time it, from step A to B, B to C, and so forth. And then look at what the bottleneck is, and then address that. If the bottleneck is the workers because they're doing a lot of, they're following inefficient instructions, I would write efficient instructions. If the bottleneck is the database, I would find ways to better organize the database. Maybe it didn't need to have 10,000 cabinets. Maybe I could have done it in 1,000 cabinets instead. Maybe I could have used indexes, right? Maybe the bottleneck was your server was producing tons of data and sending that back, but it took forever for that data to be sent back. So then you compress, you zip, you remove high-resolution images that really don't need to be high resolution. Designers like that, but I don't like it. And customers don't like it. So you do those things. Okay, you find the bottleneck and you address it. Okay, almost always that is the answer, but we're not done yet. Okay, so imagine, okay, you did all of that and my IKEA store is prospering. Workers are working really well. The database is really optimized and it has indexes. I'm using the right database types that's optimized for the right size of the database, and everything is working well. And then let's say it was working well for a while, and then I get popular and the store gets popular, and now I got the waiting problem again. What do? Do you then just go and buy a bigger store, a more expensive computer? So instead of paying $10 a month, now you're paying $200 a month for a big server with a more CPU and more RAM, right? More CPU and RAM, all that means is you can hire more receptionists and workers and database. That's it. So is that going to fix the problem? Right? That could help, but I would say there are other things that you need to look at. Okay, so imagine that the example I like to use is Yahoo. I haven't used Yahoo for a while, but imagine at Yahoo you go and on the home page, there are, let's say, top 20 news of the day and other things, right? But let's focus on that top 20 news of the day. And Yahoo, being such a popular website, let's say, and this is the Yahoo server. And again, we don't care what language, the Yahoo server was built in. It could have been any of them. It doesn't matter for us at this point. But imagine that the Yahoo site was built and a lot of the people are coming to yahoo.com server and they're requesting information. They're all waiting in line. I want yahoo.com/sports. I want yahoo.com, the main page. I want yahoo.com, blah, blah, blah. All right, all different requests. But let's say that 99% of them want to just see the home page. And the home page has top 20 news of the day. So imagine now you're the warehouse manager and you're observing what happens. Customer 1 walks in. I want the Yahoo's homepage. Receptionist hands it off to the worker. Worker goes to the database. Warehouse manager goes and finds the appropriate top 20 news from the different cabinet. Returns it to the workers. The workers assemble it really, really quickly. Right? Give it to the receptionist. Okay, I'm done. Here you go. Second customer. I want the homepage of yahoo.com. Okay, receptionist hand it off to the worker. Worker, warehouse, workers, receptionist. Okay, I'm done. Okay, what's next? I want the homepage of yahoo.com. Okay, imagine 1 million times that happens and you will be really tired. Okay, is there a better way? If you observe that as a manager, right? What would you do? Okay, let's say that the warehouse manager got really smart, and it's like, okay, hold on. I'm going and I'm walking all the way to these cabinet drawers. And it's taking me a time, but nothing has changed in my cabinets. The top 20 news hasn't changed. Why am I even walking and opening 20 drawers and getting copies of these records, putting in the copy machine, copying it, and then giving it to the workers? So then the warehouse manager says, oh, nothing has changed, so I'm just going to give a copy to the workers. So the worker comes and says, I need top 20 news. And you're like the warehouse manager, the manager, the database manager says, okay, here's a copy. They don't even open the drawers. How much faster do you think this warehouse manager would be compared to actually walking over and opening the drawer? A lot faster, right? So that's called caching. And that's caching in the database. Okay. Let's say the workers now caught up and they're like, okay, well, actually, this is cool. Maybe I can use the same technique. So the receptionist hands off the worker, like, I need the homepage of the HTML, CSS, JavaScript for the homepage of yahoo.com. Workers are like, you know what? The database manager didn't tell me anything got changed. So here's a copy. I'm not even going to assemble the furniture. I'm not even going to, I know the final output needs to look like that. So here's a copy. Boom. They skip all of that work, traveling back and forth, to create that final copy of the HTML, CSS, JavaScript, using all that logics and for loops and functions and if and else statements. Instead of that, it just creates a copy of it and says, here you go. So they can do the caching too. Let's say the receptionist got smart and they don't even now hand it off to the workers anymore. Oh, you want the home page? Okay, here it is. They can do the caching too. Your internet service provider, before they actually send the traffic to your web server, they can also cache it too, couldn't they? And say, oh, you want that? Let me just send you a cached version, right? CDN, right? When you're looking for some JavaScript files or other things that are very commonly used, it's just cached. Don't have them actually come to your server. Just have it, come to some of the other sites and, get it. How about your browser? Instead of sending that request that goes to your server, couldn't the browser also have a cache? So then if you're loading an image that was requested before, instead of actually going to yahoo.com and saying, hey, I know I came just 2 seconds ago and got this image, can you send it again just in case? They could just cache it too, right? And serve that copy. So caching can be done at multiple levels. And if you cache things, it can speed things up dramatically, right? Okay, so those are the things you do, right? As a rule of thumb, what you want to do is you want to optimize a single server extremely before you just go and buy more computers. Right? And this is often the mistake made by a lot of junior developers is they may just think that the solution to fix scalability issue is to buy more computers. No. Usually any performance improvements in that bottleneck will make things 10 to 100 times faster. Each bottleneck. And my personal opinion is if you have like an average web server and you have less than 1 million people visiting your site, a server that you're paying $20 a month should be more than enough. If not, you haven't optimized a single server yet. Optimize a single server using some of the techniques that I talked about, and you should be able to handle a lot, okay? All right. So once you optimize the bottleneck, let's say you are pulling every single resource available in that computer, the CPU, RAM on the disk, and you optimized everything. You've done some caching because you thought that's a smart thing to do. You optimize the database, you optimize the workers' instructions, right? Everything is really streamlined. You made sure that enough CPU memory was allocated to your database, enough CPU memory was allocated to your processes. You made sure that none of the CPU and RAM that was available are being used by programs that you don't need, right? So you optimize all of that. And now you're having scalability issues again. Then what do you do, right? What you do then is you get a better computer that has a higher CPU, RAM, disk. And now instead of 3 receptionists, you can hire a lot more. Because a lot more CPU and RAM, and this basically means you can hire more workers. Okay, so this is what you do. Okay, after you've done that, if let's say it still has issues and the database becomes an issue, then you pull it out. You pull the database out and you get their own store. So you get their own computer and you have them use all of the resource available in that computer for the database. This is called the database server. Okay, makes sense? That's not hard, right? Let's say even after you did that, your website gets a lot more people and you need to scale it further. Then you get more database servers. And there are a few different ways to do it. I'll just describe one of the ways to do it. Is you basically create copies, clones of the database server, and you tell the workers, okay, workers, because I have several database servers now, I'm going to create receptionists that you guys should talk to. And the receptionist will tell you whether to go to this DB server with this IP address or this DB server with this IP address. It's receptionist, right? But they also balance the load, right? It's called a load balancer. It's just a fancy word for receptionist. So you can do that. And then, as you get a lot more people, you can just increase up and down the number of database servers that you have to manage that flow. So if there are not that many people, the load is low, you reduce the number of database down to maybe 1 or 2. If the load gets a lot high during certain time of the day, you scale up the number of database servers you have, right? Now, imagine all of this is still working under a single web server, right, over here, with multiple database servers. Let's say these guys become the bottleneck now. Well, same thing. Let's just get more computers with receptionists and workers. And now, instead of customers going to these computers directly, let's set up a receptionist again. So people wait in line here. And then this receptionist will say, oh, you need to go to that one, or go to that one, or go to another one, and so forth. Okay, I can set up a load balancer here. And that's it. That's so easy, isn't it? I can scale up the number of web servers I have, or I can scale up the number of databases that I have. And I can scale it up and down. I can write computer instructions here to reduce the number of servers available that are used for the middle step or this step, right? Theoretically, it's not hard to conceptualize. To write these programs for your developers, it's going to require some work. Okay, so that's a little bit about how to organize the IKEA store. Okay, let me go a little bit more in depth. I hope it's not so overwhelming. Analogy is beautiful. If you use the right analogy, things could make sense really quickly. If you use a wrong analogy, it actually causes more confusion than helping. So a lot of my education journey has been trying different analogies, finding out what analogies work, what analogies are just confusing people more. You stop using those and you try to find good analogies to explain concepts, so that once you explain it, if they're like, oh, that's not that hard, you've succeeded as an educator. All right, so kind of at a high level, right? We talked about how you can have load balancers. You can have web servers with receptionists and workers. You can have another load balancer, and you can have database, right? When you see things like this, it's going to make sense. It all started with a single IKEA store, and I optimized it. Well, this is what back in the day people had to do, right? So setting up all these servers required a lot of work. You have to write programs, find detect the load. Oh, there's a lot of load here. This server is getting really busy. Go in and get another. Go in and get 3 more servers. You write a program to do that, right? That was a lot of work. And you get your workers to work, because sometimes the workers need to have the right environment to work. And if it is not set up right, maybe you have some conflicts, then this could break. Or sometimes some of these computers are running some specific version of a framework that has security flaws. That happened back in the Rails, where there was a massive security flaw where any web application is built in Rails, anyone could hack into, and it was discovered pretty late. So it caused a big scared movement. But it's not Rails only. If you're using some outdated software that has some built-in security flaws, maybe some ports open for some of these computers, people can hack. Even if your code was perfect, maybe the framework that you're using, version 1.5.3, has security flaws, hackers can hack and get into the system and find a way to pull information from the database without you knowing. All right, so that's going a little bit more advanced than what I initially planned on talking. But again, this analogy, I hope will help you put all of those things into context. Okay, so lost my train of thought a little bit. Where am I going with this? I mean, there are just so many different areas that we can go and talk about. But we were talking about how some of the frameworks or some of the operating system could have security flaws. It's a lot of work to manage the environments of the servers to make sure everything is working the way we should. If there's an error, to report so that there's a fail-safe mechanism. So all of that work was what was considered to be the work of what DevOps do. They would set up these servers and keep an eye on how the server is doing, monitor, scale up and down, write scripts. This was a lot of work, right? As you can imagine. Things have shifted now. And there are few things that happen in the space. So now big services such as Amazon, AWS, or Microsoft, Google Cloud, I mean all these major cloud services also now provide services so that you can basically, instead of you handling the database, for example, Amazon RDS, relational database system, for example, or maybe that's not the right short words for RDS, but it manages relational database. You can just send it directly to them and they can scale up and down, right? Even some of these things you can do, okay? Now let me introduce an advanced concept. The example that I showed you, remember that the server represented a computer. Let me draw the computer like this, where this is the computer. Every single computer that you have needs to have an operating system. So I'll say OS. It could be Linux, it could be Mac, it could be Windows. And on top of the operating system, you have to install some software, okay, on top of that, and then you get your code working right over there. So that's how the computer works. So it used to be you rent a computer in Amazon or Microsoft, Azure, or different services, and you get a computer, you install an operating system, which consumes a lot of CPU and RAM and disk. I mean, do you know how big these operating systems are? They're big. They take a lot of CPU and RAM, right? And again, DevOps did that. They install the right operating system. Oh, there's a new version. They would go and update it. Sometimes updating the operating system or some of the software would break your code. So then they got to manage all of that mess. It was a lot of work. So this is kind of the traditional way of setting up servers. But now, recently, let's say, don't know the exact year, but let's say 2014, maybe 2017 and beyond, there's a new movement. And this technology was available before, but now it has really kind of becoming more common or popular. It's called the containerization. I'll just call it containers. Containers are interesting because instead of getting a computer with the operating system, which consumes a lot of memory and CPU, it doesn't have the operating system. It just has your code. And I'm giving a very simplified version of what containerization is, but it doesn't need, no need for OS. So it's a lot lighter weight. And some of these, back in the day, if your developers working on it, maybe their code works on their computer, but the code doesn't work in another computer. Why is that? Because they're using a different operating system and they have different software that may have conflict. So you could imagine software development was tricky. Well, it's working on my Mac. It should work on your PC, was the conversation that happened a lot back in these kind of era. Containerization is operating system independent. If it works on one, it doesn't matter because it will take care of anything that had to do outside of your code base, basically the operating system and other things, it is basically out of the equation. Handles all of that. It's beautiful. So not only it consumes less resource, you don't need a bigger computer, right? You can have a smaller computer because now all of that small computer's resource can go directly into the code instead of supporting the operating system, right? So remember back into the example when if I had a bunch of computers like this, right, and a load balancer, right, you should understand what this means. In the old days, imagine that majority of that computer was used by the operating system, the database tool, because every single computer needed an operating system. Just the fact that you don't need this operating system anymore, not only you're going to save a lot of money, but developers don't have to get into that fight. It works on my PC, it should work on your Mac. Or it should work on my Linux, Ubuntu, so it should work on your CentOS. No. Containerization has removed that. There is a higher learning curve to learn that. Docker is one of the popular containerization, and then Amazon came up with their own. You'll probably see a bunch of different types of containerizations too. And also just remember that that's what containers are. That's kind of what's shaping up. And just like there are services offered by these major cloud services to help you orchestrate and manage these different servers, there are services to help you manage these containers. So Kubernetes is some of those services. You will hear of Rancher and other tools, and you will hear a bunch more. It's just an orchestration tool so that instead of you writing all the piece of software to manage that, you can create a container and they will basically handle scaling up and down as a service. It's called platform as a service. Okay, and every single major dominant one will come up with their own and give it a name, which causes more confusion. But at the end, again, everything does boil down to fundamentals. Right? All these tools, accessories, it could be overwhelming. Don't let it overwhelm you. It's again, go back to the IKEA store analogy and say, which part of this, where does this tool particularly fit in? And if you do that, a lot of different technologies will make more sense. And I do have a follow-up video where I go more in depth on system design, and all these concepts will come in to help you understand how you can create a scalable system, whether you're using traditional servers or using containers. Okay, so I hope you enjoy this. If you haven't already, go ahead and subscribe so you can get alerted with some of the cool videos that I will be creating. Hopefully they're cool. But I hope this was helpful in helping you understand how to scale web applications. Okay, thank you.